Let's look at the calculator portion now. Well, if we flip this over the axis, let me zoom in on that guy. It's so dang small. If we flip it over the x-axis, it starts looking like this, okay? And if we draw in one washer, it's going to look like this. Can't see that part. We can't see any of this. And then we would have a hole right here, right? So it's got a big radius. Oh, and by the way, this is 5. I changed these to 5, right, on your test. So it's got a big radius that is 5. That's our big radius. The small radius right here is the function, which is x squared. So let's see, the little radius, like if you put the little radius like right there, the little radius equals the x squared. So when I set up my integral, I'm going to go from 0 right here. I'm trying to figure out how to do that. I'm going to go from 0 out to whatever this is right here in the x direction, right? So if my y value is 5, okay, so let's think about that for a second. If my y value is 5 up here, what is my x value? Okay, well, x squared equals y, right? So if I had 5 equals x squared, x is equal to the square root of 5. So I'm going from 0 out to here, which is the square root of 5. So my limits are 0 to the square root of 5, but I'm going to double that amount because that's only half of the solid. There's another half over here in the second and third quadrants, right? So I'm doubling it, and then I'm going to go pi big radius squared minus pi little radius squared, and then I'm going to have a dx for a thickness. So I like to factor my pi out front and go from big radius squared, which we said is 5. So I'm going to have 5 squared minus little radius squared, which we said is x squared dx. And at this point, you switch over to Desmos. So that's what I'm doing right now. Shoot, I should have had this set up for you before I started my video, but this probably won't take too long here. Desmos is opening up. And what I want to do is I want to go 2 pi integral 0 square root of 5. And then I want to go 25 minus x to the 4th power. And I want to have all of that in parentheses with a dx on the end. Otherwise, it won't do anything for me. So 280.992, I'm going to truncate 280.992 is my final answer. So let's see here, 280.992. And you could put cubic units if you want because we are doing a volume. Down here, I'm asking for an indefinite integral, right? And so if u equals cosine of x, du equals negative sine x dx. So I just need a negative here. I need a negative there. Now I've got opposite of e to the u du, which is negative e to the u. But I'm going to substitute my u back in, which is cosine of x, cosine x, plus some constant. On number 11, I'm hurrying because I'm running out of time here. This guy right here on number 11 just wanted you to set up a definite integral from 0 to 5. So we're going to go from 0 to 5 of that function over there, 150 e to the negative 0.16 t dt, okay? And then on number, or part C, it wanted us to estimate that using Desmos. Somebody said it would make more sense if I would have just put the word evaluate part A using Desmos. So let's jump over to Desmos real quick, and we're going to change it to 150 e to the 0.16, was it? X? Let me see if that's what it was. Let me switch back over here. 0.16 negative up there, right? So I need a negative, not 1.5. I want negative, and I want that to be a 6. And I don't want a 2 pi out front. I want this to be 5, not square root of 5. and my answer comes out to be 516.254. Always take it to 2 decimal places, 516.254, 254. And then for 5 left-hand rectangles, well, each rectangle would have a width of 1. 1, 1, 1. Hopefully this is 5. And so if my width is 1 and I want left-hand rectangles, I want to go up there and over, right? So this height's going to be f of 0 or c of 0. My function c. So let me change that to c of 0. And then the next one's going to be c of 1. And then the next one's going to be c at 2. And the next height's going to be c at 3. And the last one's going to be c at 4. So we really want 1 times c of 0 plus c of 1 plus c of 2 plus c of 3 plus c of 4. Come on, 4. And so if I jump back again over to Desmos and I get rid of my integral sign, here's my function. I could call it the c of x function. And I want it to calculate c of 1, right, plus c of 2 plus c of 3 plus c of 4. I'm missing something here. Oh, I'm missing the c of 0. We wanted to start at c of 0. And I get 558.655, 558.655, 558.655. Look how close I am, right? It's not that far off. Hey, thanks for watching the test correction videos.